We discuss the 9 body parts that will disappear one day. Number 9. The human vermiform appendix is a small, tube-like structure located near the junction of the small and large intestines. It has long been considered a vestigial organ, meaning it has lost much or all of its ancestral function through evolution. In humans, the appendix appears to serve little to no purpose in digestion or immunity. One prevailing theory regarding the appendix is that it may have been more functional in our evolutionary past. Possibly as part of a larger digestive system or as a reservoir for beneficial gut bacteria. However, as human diets and lifestyles have changed over time, the appendix's original function, if it had one, may have become obsolete. The appendix is also known for its susceptibility to inflammation and infection, a condition called appendicitis. In modern times, appendicitis can be a serious medical emergency requiring surgical removal of the appendix. Given its seemingly vestigial nature and propensity for health issues, some speculate that the human vermiform appendix could continue to diminish in size or even disappear entirely over evolutionary time. This process would likely occur gradually over many generations, influenced by factors such as genetic mutations, natural selection, and changes in environmental pressures. However, it's important to emphasize that the complete disappearance of the appendix is speculative, and its eventual fate remains uncertain. Number 8. Toes. Particularly the pinky toe, have been speculated to become less necessary for humans over evolutionary time. Historically, toes played a crucial role in balance and mobility, especially when humans were more reliant on climbing and grasping with their feet. However, with the advent of bipedalism and advancements in footwear, the necessity for toes, particularly the smaller ones, has diminished. Modern human locomotion and balance are heavily reliant on the big toe, while the smaller toes contribute less significantly. The pinky toe, in particular, has a reduced role in walking and running. Additionally, with the increasing use of supportive footwear that aids in balance and movement, the structural necessity of the pinky toe is further minimized. Over time, evolutionary pressures could lead to the reduction or complete disappearance of the pinky toe, especially if it no longer confers any significant advantage. This process would likely be gradual, driven by genetic mutations, natural selection, and changes in human activity patterns. Number 7. Jacobson's organ, or the vomeronasal organ, VNO, is a part of the olfactory system involved in detecting pheromones and chemical signals. In many animals, it plays a crucial role in reproductive and social behaviors. However, in humans, Jacobson's organ is largely vestigial and underdeveloped. During human embryonic development, the VNO forms but often regresses before birth or remains non-functional. Unlike many animals, humans do not rely heavily on pheromones for communication and social interaction. The primary olfactory system in humans has taken over most of the functions related to scent detection. Given its reduced role and underdevelopment in humans, Jacobson's organ may continue to diminish over evolutionary time. This process would be influenced by the lack of selective pressure to maintain or enhance this organ, as humans rely more on visual and auditory cues for communication. Number 6. Erector pili muscles are tiny muscles located at the base of hair follicles. When these muscles contract, they cause the hair to stand up, a phenomenon known as goosebumps. In animals, this response helps with thermoregulation and making them appear larger to predators. In humans, the erecting of hair serves little practical purpose due to the relatively sparse and fine nature of human body hair. Historically, the ability to raise body hair was more beneficial for our ancestors, who had thicker body hair for insulation and intimidation. As humans evolved and lost much of their body hair, the function of the erector pili muscles became largely redundant. The minimal practical use of these muscles in modern humans suggests that they could diminish over evolutionary time. Without selective pressure to maintain their function, genetic changes could lead to their reduction or disappearance. Number 5. The tailbone, or coccyx, is a small, triangular bony structure at the base of the vertebral column. It is the remnant of a vestigial tail, reflecting our evolutionary past when our ancestors had tails for balance and communication. In modern humans, the tailbone serves no significant purpose other than as an attachment site for certain muscles, tendons, and ligaments. The coccyx can cause discomfort or pain if injured, a condition known as coccydynia. Despite its limited function, it remains a part of human anatomy, primarily because there has been no strong evolutionary pressure to eliminate it. As human evolution continues, the coccyx may become further reduced in size or even disappear if it ceases to provide any advantage. This would be a gradual process influenced by genetic mutations and changes in human physiology and posture. Number 4. The palmaris longus is a muscle in the forearm that is absent in about 14% of the human population. It runs from the elbow to the palm and assists in flexing the wrist. In humans, it is considered a vestigial muscle, meaning it no longer serves a critical function in our daily activities. The palmaris longus was likely more important in our ancestors, who used their hands and forearms for climbing and gripping. As human activities have evolved, the necessity for this muscle has diminished. Its absence does not typically affect hand function, suggesting that it is not essential for modern humans. Given its variability and lack of significant function, the palmaris longus may continue to disappear in future generations. The process would be driven by genetic factors and the absence of selective pressure to maintain this muscle. Number 3. Wisdom teeth, or third molars, are the last set of molars to develop and emerge in the human mouth, typically between the ages of 17 and 25. Historically, they were beneficial for our ancestors, who had larger jaws and a diet that required more chewing of hard foods. As human diets have softened and dental care has improved, the need for these additional molars has diminished. In modern humans, wisdom teeth often cause problems because there is insufficient space in the jaw to accommodate them. This can lead to impaction, infection, and the need for surgical removal. Many people are now born without some or all of their wisdom teeth, indicating a potential evolutionary trend. The diminishing necessity for wisdom teeth, combined with the problems they cause, suggests they may eventually disappear from the human anatomy through natural selection and genetic drift. Number 2. Ear muscles, or auricular muscles, are small muscles surrounding the outer ear. In many animals, these muscles are well developed and used to move the ears to better capture sounds, an essential function for detecting predators and prey. In humans, these muscles are largely vestigial, with most people unable to move their ears significantly. The ability to move the ears likely served an important function in our evolutionary past, helping early humans and their ancestors to better locate sounds in their environment. As humans evolved and relied more on visual and auditory cues from the head and eyes, the need for mobile ears diminished. Number 1. Sinuses are air-filled cavities located within the bones of the face and skull. They are connected to the nasal passages and help to humidify and warm the air we breathe, enhance our voices, and reduce the weight of the skull. However, sinuses are also prone to infections and inflammation, leading to conditions such as sinusitis. The exact evolutionary origin and purpose of sinuses are not entirely clear, but they may have played a role in respiratory efficiency and cranial structure in our ancestors. In modern humans, while they still serve certain functions, their susceptibility to problems raises questions about their long-term evolutionary future.